So today I am back again with continuing with learning our C programming language session. So last time what we discussed was related to the structures and how can we use enum structures and different type of data types. How can we create different type of custom data types in order to understand custom data types. So if we try to look at the simple program, what we did is we will create a revised .c. First, let me open tmux. So here what we are going to do, for example, you want to create a custom data type. Let's assume employee. So we can use type def struct, then emp, and what are the properties inside the struct, and then here we can mention what is the type of the structure we want, the name of the structure which we want to create. So for example, now we know, for example, we are creating an employee. So employee will have a constant character pointer name, which will be a string, constant character pointer, which will be his department, and for example what is his age. So these are more than sufficient fields. Now inside our main function, if we are going to create an employee, for example we want to create an employee poor coder, we can create a new employee, like we can mention employee structure, and then inside employee structure we can give the properties which we want. For example, name. How do we define? So we define the properties as we don't have anything to do with the key. Yes. So what we do is, first we will mention the name, which will be poor coder. Then we will define his department. So let us say he's in developer department and his age is 32 years of old. So now we can access these data. For example, we want to print his name, then we can use puts poor underscore coder dot name. So it is what mistake I am doing. Fish snappy equal to, and I have done the type def struct fish and emp. Once again, let me open it again. Revise.c, going to vertical split dot slash chapter 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 5 dash struct dot c, chapter 5 struct dot c. So if we look, I'm created a type def struct emp constant character pointer. That is absolutely fine. Then it is what error it is showing here. Oh, I don't have to mention emp here. Golang programmers. I have been using Golang too much. So okay, no problem. So we have to create just write the properties here, and then we can put implicit declaration, because puts is inside the hash include stdio.h package. So we can then execute the code, and then we can execute the code using gcc dash. So we also understand about makefile. We also read about makefile last time. So first what we can do is, if we are going to mention the c file, revise.c, then we can output a .o file, r.o. Okay, then we can use gcc dash c r.o, to create a linker file or uh, r.o linker input file used because linking is not done. Sorry, r.o dash e, and then we have to mention r. What are it as r.o then r. Linker input file unused because linking not done. Linker input file unused because linking is not done. Linker input file not found, no such file or directory. Oh, sorry. R.o is there. GCC dash c r.o unused because linking is not done. Then what was the command? I don't remember actually. Dash encrypt dash c r.c. So, or we can directly run it gcc dash device.c dash or. Then I can execute directly r. So it is going to print the name. And after printing the name, if we try to, for example, if we have created a function, or we can do printf uh, age of person. Person is person d, and then we can pass the whatever is age is. Sorry, age is like emp.age. Oh, sorry, poor code. So then I will execute again. So it is going to print the age. Now there was another concept. If I'm going to create a function, sorry, I'm going to create a function like void update age, and I'm going to pass the person employee emp empe, and inside that what I can do is, for example, we are going to pass an employee age and then e dot age equal to, I'm going to change it to 22. But if I'm going to call this function update age and call it with the help of pass it poor coder as a parameter, and if still I'm going to print the age, it will still print the earlier age because we are using the actual struct, not the pointer to a struct. So it will again print the age is 32. So the problem here now is, how can we fix this problem? By passing a pointer. And here, rather than passing the poor coder, we can pass the pointer to a poor coder, address of the poor coder. And rather than referring it like this, we have two ways. Either we can use star. First, we are dereferencing that value, and then we are going to get the value at that address. Means we are getting the structure at that specific address, and then we are calling its age and updating the age. So if we are going to compile it and then run it again, you can see the age has been updated. This is one way, or the other way which we learned was e. This was the other way which we learned. Okay, so the same, the age has been updated. So let me remove this file. Okay, now it is clear. Now let's go back. CD chapter 5. No, let's see what else we have learned. Yeah, we also learned about little bit things about make file. So you can see first what we were doing, we were using gcc-c encrypt.c and gcc.c hello.c, and then gcc encrypt.o hello.o dash oh file. Okay, okay, so this was the mistake which I was doing. I don't didn't remember it. So now we can go to chapter sorry details to 5. Okay, now we are inside chapter C, so we can see gcc dash c structs.c and then gcc struct.o dash o s, and then we can run s. Okay, amazing. So I forgot this rms structs.o file. Okay, now let's continue with our further learning. So now here is some information about, I think sometimes you want to control at the bit level. Let's say you need a struct that will contain a lot of yes no values. You could create a structure with a series of short or ints, short low pass PCF, short filter compiler, short reverb, short sequential, and types synthetic. And that would work. The problem, the short field will take up more space than the single bit. It is saying that we need only struct with yes no values, only a single bit. So the short fields will take up a more space than the single bit you need for true false. Okay, the size. It's wasteful. It would be much better if you could create a structure that holds a sequence of single bits for the values. That's why bit fields were created. Structure that could hold a sequence of single bits for the values, only single bits. So those are called bit fields. When you are dealing with binary value, it would be great if you had some way to of specifying the ones and zeros in the literal, like x equal to 0, 0, 1, 0, 1, 0, 0. Unfortunately, C does not support binary literals, but it does support hexadecimal literals. Okay, every time C sees a number beginning with 0x, it treats the number as base 16. Okay, okay, okay. This is not decimal 54. Okay, 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 okay. 5 and 4. But you can convert back and forth between hexadecimal and binary, and it is easier than ever converting binary and decimal. The good news is that you can convert hex to binary one digit at a time. So this is a hexadecimal. Hexadecimal means 4 byte. This is 4 bit. This is 4 bit, and 5 means 10101, and 4 means 0100. Each hexadecimal digit matches a binary digit of length 4. All you need to learn are the binary patterns for the numbers between 0 to 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then A, B, C, D, E, F. Those are hexadecimal numbers. So a bit field lets you specify how many bits an individual field will store. For example, you could write your struct like this. Okay, this means the field will only use one bit of storage. Okay, one bit of storage. So we are creating an unsigned int, low pass VCF, one bit, filter compiler, one bit, one bit, one bit. Each field should be an unsigned int of one bit. By using bit field, you can make sure that each field takes up to one bit. So let's try to create a bit field. And we will create our main function here, and over there we will create our struct type depth struct, and what will name bit field, or what else happened to spelling field. And then here we are going to mention our strict bit f is more than sufficient. Okay, then what we are going to do here is, so unsigned int, what are the low pass VCF, and it's only one bit, it will occupy only one bit. Unsigned int filter compiler, uh, compiler colon 1. So I think these two are sufficient. Okay, if you have sequence of bit fields, the computer can squash them together to save space. So if you have 8 single bit fields, the computer can store them in a single byte. So this is the point which it is trying to. Okay, so it will squash them together to save space. So we are creating a structure with 8-bit fields. So it will only occupy the single byte and will store that in one byte. Whole structure will get stored in one byte. Yeah. So how many bits do I need? Bit fields can be store a sequence of true false values, but they are also useful for other short range values like months of era. If you want to store a month number in a structure, it will have a value of 0 to 11. Yes, you can store those values in 4 bits exactly. Why? Because 4 bit lets you got it, unsigned month number 4. Amazing. Okay, so is this your will you come back again? First visit 1, will you come back again? Yes, true. Number of fingers lost in piranha tank 4, because we have only 4 fingers. 1 in days a week 3. Why? Because 7 can be stored in 3 bits. Got it. So a union allows you to store different data types in the memory location. A designated initializer sets a field value by name. If you declare union with a value, I am not interested in using union method right now. Okay, data structures and dynamic memory. Now we are going to the most important and difficult part. So there was a video about how NASA uses C programming languages and what are the strict rules they follow. And the one rule of them was, I was watching this video on the YouTube. So, and the one rule they mentioned that they don't use dynamic memory at all in their code. They only use static memory. I'm not sure how true is this information, but this was being mentioned in that specific video. But still, we have to learn about dynamic memory because it causes some sort of memory leaks. We will understand that what are memory leaks maybe in this book, or we will keep on understanding from somewhere else. So, to model complex data requirements, you often need to link structs together. In this chapter, you will see how to use struct pointers to connect custom data types into large, complex data structures. You will explore key principles by creating linked list. Amazing. You will also see how can you make your data structure cope with flexible amount of data by dynamically allocating the memory on the heap and freeing up it when you are done. And if you are good housekeeping becomes tricky, you will also know how Valgrind can help to detect the memory leaks. Exactly, that's the point. Do you need flexible storage? You have looked at different kinds of data you can store in C. Obviously, we have seen that, but sometimes you need to be a little more flexible. Yeah, definitely. Imagine you are running a travel company that arranges flying tours through the island. Each tour contains a sequence of short flights from one island to next island. For each of those islands, you will need to record a few pieces of information. Name of island. So this is the information. Name of island. Opens. What does opens? I don't know what opens means, but closes and opens, and then island. And we are going to create a island, four islands, an array of four islands. Yes, but there's a problem. Array or a fixed length, which means they are not very flexible. That is the point at all. But what if you need to change the tour? What if you want to add an extra destination in the middle of the tour? Yes, linked lists are like chain of data. So we are going to understand linked list here. So linked list does not have some sort of static length. So we can keep on increasing the size as soon as the elements get added. Abstract data structure, because a linked list is general, it can be used to store a lot of different types of data. Yes, a linked list stores a piece of data and link to another piece of data. So this is the linked list. So Amity will point to the Craggy then point to the Isla Nublar, then Shutter, and Shutter can point to the skull. Okay, so it is a simple linked list. You need to create a new flight from Craggy to Skull, and then Skull to. For example, he is saying that we can change the path from Craggy to Skull, then Skull to Isla Numbar, then Shutter. So this is an array. Okay, how do you create a linked list in C? So let's try to understand. Sorry. So bitfield is fine. Let's go to cd.mkdir chapter 6, cd chapter 6. Then we are going to linked list.c. Okay, and here first we will create a type def struct, and then we will create an the structure as island. Okay, then we are going to define some of the attributes of the structure, and first attribute is character. What is the name of the island? Sorry, uh, name of the island. And then the second is when it opens, and the next one is closes, and the character pointer to island, which will, sorry, island pointer, which will define the next island. But this was not being, so this is throwing an error. You must give a struct name here. So this will not work if we are going to use it like this island. It's only work if I are going to use it like this. Now it works. Okay, because it is unknown to this. Now what is the structure? So it is pointing to the next island, and these are pointing to the attributes of the same island. Correct? Yes. Then now we have to, for example, create an island. Let's try to create an island. Um, so first island, our what were the names of the island? Amity. Okay. So first name is Amity Island. So island Amity equals. We are going to create a structure, and the first will be the name. The name will be Amity. Closes opens. I don't understand what opens is. Let's assume 10. Closes at 22, and then the next island. So now we are going to create a next island, and how can we create it? I think it can be done in the same way. Island. I'm just trying. I'm not sure. Amity goes to Craigie, but Craigie goes to this. What we can do, we can create it in reverse order. Okay. So once again, island. The last one is shutter. Just trying, just trying. Then we will look at the book. Shutter. Shutter opens at 9 and closes at 21. Sorry, 21, and then it has nothing next. Oh, Lil, come on, man. How can I create an empty structure like this? Empty scalar initialization, and then emity. We're not talking about every isla. Now the isla, okay, and this is isla. Isla, and here in isla we are going to pass shutter, but it is a pointer, so we are going to use the address. Okay, 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 okay. So we are going to use address of island. Am I correct? No, island. Expected expression before island. What expected expression? I'm not sure. So we have to check it off the book. How they are doing it. Null. Okay. Oh my god. Amazing. So we are going to point it to null and use variable shutter. I'm using shutter here or address of shutter. SHUTTR, or we can use null here. Oh, sorry, my mistake of SHUTTR. Now it is fine. Yes. Now what we can do is we can, for example, want to refer to what is the name of the island where after Isla. So what we can do, put Isla dot, sorry, not dot, because it is an we want to Isla. We can use dot next island. Let's go island. Then we are going to refer that as what will be its name. Okay. So here we have to use hash include stdio.h. Now gcp dash c. What was the name of the file? ll.c. ll.c dot o dash ol. So we are going to run l shutter. Exactly what was the name of that. And why did we use arrow sign here? Because this is a pointer, and in order to refer the variables from a pointer, we have to use arrow sign. Correct? So we also did the same thing, and rather than what they did is they just mentioned a null, and then they mentioned the dot next. In next, they are going to refer to that specific address. To set next field in each island to the address of the next island, you will use struct variable for each of these islands. So now you have created a complete island, or in so we have created only two, but we can use a third one also. The third one is we can use emity uh, and, and emity. Let's assume emity is referring to, come on, emity is referring to Hizla. This dash cll dash c dash this cll dash c dash ol. Okay, amazing. And then we can also refer to, we can change the order, maybe puts emity dot name. Correct? And it will be better. So what it will show is image. Sorry, is it because so first point is empty, then empty, then we will go to this and then we will go to shutter. So it is a sort of linked list we have created. Okay. So now what is it? Code magnet. Why display island start? Got it. So what they are trying to do is they are only creating a start. So rather than doing this, what we can do here is we can create a void display, the name of the right. And here rather than passing the all the structures, we can pass the starting, which we call the head. And then what we are going to do is uh, we will create a while loop while head next is not equal to null. We will keep on moving to the next item. Okay, while head next. So head is a island, and island has a value next, and we are pointing to that next until it is not equal to null. We keep on moving. We keep on printing uh, head dot name. Sorry, we can't. That is a pointer name, and what we are going to do here is we will print the name and head dot next underscore island equal to head equal to, we are going to use head next island next underscore island. The mistake we did here was that it is not next, it is next island. Okay, so rather than calling this, we will call our display method, and inside display we will pass address of met. And now we will compile this code and run it. So met island, but shutter is not getting printed because while head next island is not equal to null. Okay, or so what we mistake we have done is we are checking the next is not equal to null, or we can check while head is not equal to null. Then if we run the code, then shutter is getting printed because at that specific point of time, head if head next is null, then that means that head will be point to shutter. So we are not printing the shutter, and this will work fine. Okay, so we did the same thing. Is not equal to null. Next name open closes. So we are printing all the values, and we are printing just two values. So it is clear. Now let's move on. Yeah. All the programs you have written so far use some sort of static storage. Every time you wanted to store something, you have added a variable to the code. These variables have generally been stored in stack. Remember, the stack is the area of memory set aside for local variables. Yes. So when you created the first four islands, you did it like this. Exactly. Yeah, absolutely. We did it like this. So yes, so we have been trying to understand that each island struct needs its own variable because we were at the compile time we knew that there were going to be four variables, but what if we are going to use more than four islands? We don't know that at the specific point of compile time, so we have to dynamically allocate the memory. So we have been also earlier read about the different types of memory blocks. Static memory, whenever we create a variable inside a function, that gets stored in a stack memory. So yes, and there was constant memory. Whenever we create a constant variable, that gets stored inside constant memory. What the code block memory, whatever assembly instruction, those are get stored inside the code block, global memory, and then there is a heap memory. So for dynamically allocation, we use heap memory. The stack area is the memory that is used for local variables. Each piece of data in the variable and each variable disappears as soon as you leave its function. So that is the point of stack memory. The trouble, it's harder to get more storage on the stack at runtime. That's where the heap comes in. The heap is the place where program stores data that will need to be available longer term. It won't automatically get cleared away, so it means it's perfect place to store data structures like our linked list. So how can we get it? We can get our memory by using malloc. This is like bit like asking for a larger storage locker for the data, and in C, you do that with the function called malloc. You tell malloc function exactly how much memory you need, and it asks for operating system to set that memory aside in heap. So we are going to exactly tell it how much memory we are going to need in our function. The function returns a pointer to the new heap space, a bit like getting a key to the locker. It allows you to access to the memory, and it can also be used to keep track of the storage locker that has been allocated. So it will directly return us the address, and with the help of that address, we can use that or keep track of that memory. Okay, so they are making an analogy that key is like a address. The address is like a key, and we can use that key to the locker. So whenever this is the most important point, give the memory back when you are done. Whenever our task is done, we have to free our memory. The heap has only fixed amount of storage available, so be sure to use it wisely. The good news about heap memory is that you can keep hold of it for a really long time. The bad news is you can keep hold of it for a really long time. So when we're just using the stack, you don't need to worry about returning memory. It happens automatically. Garbage collection, it is not sort of garbage collection. Garbage collection is in latest programming languages like Golang or Java. Whenever the memory which is being created in heap, it is the responsibility of the compiler to clean that memory if that memory is not used. There are different algorithms for that. The heap is different. Once you are asked for space on heap, it will never be available for anything else until C standard library, until you tell the C standard library that you are finished with it. So we have to annually tell the compiler that releases memory. And heap memory is also fixed, so we have to use it very wisely. A memory leak happens when a program asks for more and more memory without releasing the common memory it no longer needs. So how can we free it? By calling the free function. The malloc function allocates space and gives you pointer to it. Okay, and the free, when we will finish using this pointer to access the data, and then when we are finished with the storage, we need to release the memory by using the free function. Okay, now how can we ask for malloc? So it is used inside stdlib.h standard library, and we are already using it. Okay, so okay, now the function that asks for memory is called malloc for memory allocation. Takes a single parameter, the number of bytes that you need. And how we are going to know the number of bytes we are going to need? Most of the time you probably don't know exactly how much memory you need in bytes. So malloc is almost always used with an operator of called size of. So it is used with an operator called size of. Size of tells you how many bytes a particular data type occupies on your system. It might be struct, or it could be some basic data type like int or double. So we are going to create an island, pointer to an island. Okay, malloc size of island. This means create enough space for an island and store the address in variable p, and free up the memory with free p. So as simple as that. So we are going to create a dynamic memory and free it with p. Free needs to be given the address of the memory that malloc created. Same point. Exact address that malloc has been created. Malloc returns you the address, and you have to pass it to free. Okay, now we know more about dynamic memory. We can start to write some code. So island, okay, we will create an most difficult work. So what we are doing here is we are using a create function. We are only passing the name, and we are creating an island, and we are assigning it name, open closes, next null, and returning the okay. So we are going to use a create. Okay. So we are going to create a function create, and what does the create will return? Create will return an island, not an island, but a pointer to an island. Okay. Now what it will take as a parameter, maybe name. So when we are going to create island p, and what we are going to do here is we are going to create a memory block for it with the help of size of operator, and inside size of we are going to pass the structure for which we are we need the memory. Okay, then we are now using a pointer, and we can assign name equal to name, uh, opens equal to 10, p closes equal to, for example, 23, and then p next we don't know about next it is equal to null, and we will return that. So we will create, and then when we are done with it, we will destroy. So destroy takes a pointer to an island, and it will free the memory. So we were passing the MAT here. Now what we are going to do here is we are going to create an island pointer to island, and this island Isla Imashasi last. So let's name it last. Equal to, we are going to call the create function, and we are going to pass it a name last, and then shutter dot next equal to last. Shutter dot next equal to last. No, not last, because it is a pointer. So it is pointed to an island. Why is it showing an error? Island has no member next. Oh my god. Next island. Once again. Next. Next island. Okay. Then we are going to display, and then we are going to destroy the memory which we have created last. Okay. So let's see now. You can see emitting, ILA, shutter, and last. And we also freed the memory which we were using earlier. Amazing. Easy to understand. Okay. So we are going to return whatever we are using, and then inside island, then we call the it is asking about name. Okay. So what it is doing, it is dynamically creating a linked list, I think. Island p0 create name. So whatever we are going to pass the name, it is going to create an island for it. So we next it will keep on asking display p island 0. So this is the same thing which we did. Closes I, opens I, next null, return I. It is just the only difference, it is using fgets to get the value from the standard input. Yeah, stdim. Amazing. Now in C you often need to make copies of strings. You could do that by calling malloc function to create a literal space on the heap, and then manually copying each character from the string you are copying to the space on the heap. But guess what? Other developers got ahead of you. They create a function with string.h header file strdup duplicate. So character pointer to string, character pointer copy equal to strdups. So we will create a duplicate string, create a memory in the heap. So it creates a memory in the heap. You have to remember that somewhere in the heap. Str function works out how long the string is, and then calls the malloc function to allocate the correct number of characters on the heap. It then copies all the characters to the new space of the heap. That means always creates a space on the heap. It can create space on the stack because that's a local variable. It can't create a space on the stack because that's a local variable. Local variable gets created way too often because stdr duplicate puts new string on the heap. That means you must always remember to release their storage with the free function. Got it? Okay, so we can see that only need to put str duplicate function on the name field. Can you figure out why that is? Let's fix the code by using strdup. So what was the issue in the code? Create name. The case of vanishing island. What happened to the name of the first island? So it is creating an island. There is some issue we have to understand. So it is asking Atlantis to create. Okay, fgets name the island, pointer p island equal to create name, next island p, back at the headquarters tidying up some paperwork, display Marsh Island. Okay. So this creates a second island, create name island 0, Atlantis, fgets name 80 std. So what is the problem? It passes a name, create name, its name. Okay, what happened to the name of the first one? Is there is a bug in create function? Does it away? It gives any clues? Look at the quote of create function. So what it is doing is it is assigning the name variable which you are passing uh, to the element of the island structure. When the code records the name of the island, it does not take a copy of the whole name string. It just records the address where the name string lives in memory. Is it that important? Where did the name string live? We can find out by looking at the code that was calling the function. Okay. So we were using a pointer. Oh, so they are saying that we were not passing the name. We were passing the pointer. So here we are also pointing the passing the pointer. Here we are also passing the pointer. So as soon as we did it, we updated the name. Mm, that was right, correct. So this was the problem. Rather than using string duplicate, so what it is saying is I got it. Um, so we can also write that code. Rather than creating a name, we can use character name 80, for example 87, whatever we want. Then we can use fgets, and in fgets we have to pass first the name of the variable name, and then how many characters we want to read, and then what is 80, and from where we want to read stdin. Okay, correct. And we are going to we will change the name of it to it is not correct last but second last. Okay, and then rather than shuttered at next line we will use last two, right? Change and double quotes, and here we will pass the name. Then what we are going to do is we are going to fgets again name, and then last two we will use last, and last two dot last two's next underscore island will be equal to create, no sorry, will be equal to last, correct. Then we will display destroy last, we will destroy last one last also, correct. Okay, gcc, and then we are going to execute our function. So it will ask for last two and then last. So You can see it was printing last and here also last, but expected value was to print only last. Okay, last two and last. So expected was to print only what do we call that, last two and then last. So it is saying that we are passing the pointer here. So rather than when we get the memory uh, address here, so what we can do at this point of time, so we have the address and we want to pass that address to there. So we can do here is we can create a character pointer here directly. For example, dupe name equal to name. Okay, so this will live in the this specific dupe name will live only inside the stack. So we will call here. Okay, fine. Now let's see what will happen. So last to last. Again, it will print the last because I don't understand why this happens. So what I'm passing here is I'm also passing the address. Mm, Here also we pass the address, and what we can do, character do equal to, so this will not work. It will only create a character. This will absolutely not work. So we are passing a pointer here, and passing a character pointer here. How can we fix it without using the heap rather than using the stack memory? So here we have an address. Okay, address, and what we are doing is we are updating the same address location, and fp name also refers to the same address block. What you want to do rather than passing the address. So what I was trying to understand here is the address. Both now but it is the same address. Is it? So both are now pointing to the same address. Group name also contains the address, but pointing to the same address. But what I want to do is I want to copy it to a new address. That's why they are saying we can use a string to, but I don't want to use the heap memory here. I can work with the stack memory here also. I just want to. What about strcpy? So can copy the contents. So let's go to the documentation of strcpy and page. So uh, pointer destination source string pointed to the source include the terminating the null byte to the buffer pointing to the destination. Beware of buffer overflow runs. So it can cause bugs. If the length of the string is less than n byte to destination to ensure the total. So one second. What I was thinking is, so what I can do, let dupe name, which is also of size empty. Okay, and dupe underscore name equal to name. Dupe underscore name is an array, especially with array type. So it is an array. So on right side of the operator, it returns the address. So what I can do here is enter for while loop, enter a while loop, and un, index equal to index equal to 0 while uh, tube underscore name tube underscore name sorry. So what I can do so character name while value at name. Let me think about it. So pointer first and it will point to name. Okay, so what I can do is while value at first is not equal to backslash 0, so while value at first is not equal to backslash 0 and and index less than 80, x must also be less than 80. What I can do is I can tube underscore name index equal to value at first, and what I can do is index increment by 1 and first equal to first plus 1. Okay, and then I have the name pointing to duplicate name, and this duplicate name has been created inside the what do we say inside the in the stack memory, and I think this must work. Last to last 1 1 so no, last MT आएगा shutter 1 1. So I think first 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 plus no, that is the same thing. Last two. Oh, so there are some issues, but I'm doing first value at first is not equal to the dupe name index equal to value at first. So what we can do here is print dev percent comma value at first. So last two. Okay. So last two goes here. What I'm able to understand, last two goes here. It calls the it will create and it prints all the last two here, and then I call the last. Then it goes back there, creates last, empty ILA shutter. But what it is not doing, next p dot name to tube name are because the index. So what is inside tube name? What is inside tube name here? Print or puts tube name. Last. Absolutely, it is correct. It has correct value. Tube name last, but p name is pointing to tube name. Then we are going to pass display ID tube name. Okay. That memory has been destroyed. Got it. So the problem here is arising because p.name is pointing to this memory address, and that memory address has already been destroyed because we are out of heap. Yes, that was the problem. That's why we can't solve this problem without using heap. Because what is happening here, what I'm trying to do here is I have created a duplicate name inside the stack. Okay, and I'm assigning this name address to a tube name. Exactly. Now what is happening when I am in this code block? So it absolutely correctly prints the last two value. But as soon as I escapes this function, I return from this function. Sorry, I return from this function. This stack memory is freed, has been freed, and it does not represent anything. And this p.name points to this empty memory, and that's why it is printing this. So that's why this is not a correct solution. Okay, so you name not, we have to point to name. Got it. So now what it is, now what the book was saying, that's why they were explaining this solution. We have to use str, this strdup, char copy, pointer to copy, equal to strdup, and we have to use the string which we are going to use here, and then we can copy here without a cast. Why cast? So the new code is what kind of cast? It is showing name. Why cast? strdup hash str dot h compiled correctly. Last to last. Now it will parameters were shutter to last and last. But the point here is this memory. We didn't free this memory. That was the problem. We are not freeing this memory. We are creating a string tube. Okay. I am not sure how can we do that. It's because we are setting open closes field to string literals. String literals are stored in read-only area of memory set aside for constant values. Yes. You can see that we only need to put the strdup function on the name field. Can you figure out why this is? Because we are using string literals here. In these two, we are using string literals, and it is stored in a read-only area of the memory set aside for constant value. But it's a constant. Yeah. That's why we don't need it here. So does it fix the code? Yes. Bool puzzle f gets name stdi not equal to null, I equal to next. So it has created a rule loop now, and until not equal to null. So keep on creating, and then it will automatically ask for the byte and create a list based on that. Okay. Now we have created a release island, and similarly we have created a destroy and destroy release island. But wait, you are not done yet. Don't forget that you have allocate space with the malloc, and you need to free the function. Yes, and inside next equal to, I think it has two free. It has free I dot name. Yes, this is the solution. This is the solution I was thinking about. So destroying, we have to first just free p name. Yes, and then we have to free because this was being allocated on heap. So free p dot p name and then free p last to last. Yes, and it has also freed that memory. So what they have done is rather than using this, they have used a loop for that. Yes, they have some. So I think now we are going to read about some other data structures, W linked list, tree, linked list. So I think this is enough for today. 1 hour stream. So I will try to get back tomorrow and we'll continue with learning more about the same topics. Thank you.